Hello nerds, welcome to my channel. You're watching Math Equals Music. In this video, we're going to talk about math, we're going to talk about music, and we're going to talk about the relationship between math and music. Let's focus on introductory music theory and algebra. And by introductory, I mean beginning band day one. Beginning band. Okay, enough of that. Sometimes math can seem really abstract and daunting. Okay, so we have to take the integral of the hyperbola across the region represented by the exponential function. And music can seem a little esoteric at times. Okay, I'm gonna play a C flat sus dominant 9 over a rooted harmonic. And although they seem unrelated, I believe that math and music have a lot more similarities than differences. So satisfying. Let's get started with music, with a beat at a tempo of 120 beats per minute. That sounds like this. In common time, 4 beats are in one measure, and we count like this. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. If we play a note on the piano with the duration of 4 beats, the whole measure, we would call it a whole note, which sounds like this. Different notes have different pitches, so we can create a tune. Play multiple notes, that's a chord. If you divide the whole note in half, you get the half note. Divide it half again to get the quarter note, and again to get the eighth note. So that's some intro music theory in about a minute or two. Add a little pizzazz and you might get a pop rendition of classical piano. Next, I want to talk about math, in particular functions in algebra. A function is like a box, a computer that takes a number as an input and spits out another number as an output. Let's do an example with the function f of x equals x squared. So x is the input and x squared is the output. If the input value is 1, 1 squared is 1, so the output is just 1. If the input is x equals 2, the function takes in f of 2 to calculate 2 squared and outputs 4. Functions come in many shapes and sizes. They can be represented by equations or visualized by graphs. Keeping functions in mind, let's talk about the math of music. Exactly how long should we play the notes? A whole note is 4 beats, so dividing by 120 beats per minute and multiplying by 60 seconds per minute, we'd hold a whole note for exactly 2 seconds. Similarly, a half note played for 2 beats is held for 1 second, and a quarter note, a single beat, is played for half a second. In general, we can write the equation d equals 60b over t, where b is the number of beats, t is the tempo, and d is the duration in seconds that we hold the note. Knowing this equation or calculating by hand, we can fill out this table for the duration of notes at 120 BPM. So a whole note at 4 beats is held for 2 seconds, a half note or 2 beats is held for 1 second. And as we continue to fill out this table, see if you notice any patterns. For this next part, we're going to make this a little bit interactive, so if you're interested in following along, click the link in the description. We're going to jump right into Desmos. So we're going to do a little workshop, and I'm going to show you how to graph some functions on Desmos. So Desmos is great. I'm actually quite new to it myself. So we can have our own variables. So if I have an input variable, I want to call it I. Let's say I is 2, and I can have an output variable. I'll say O, and I can say O is I squared, just like before. Okay? And the great thing about Desmos is you can change I for any input you want. Okay? So I is changing, and we can see the output variable as a function of the input variable. So rather, what we're going to do is just plot functions, and with Desmos it's really easy. I'm just going to say whatever function I want, say the function is x squared, then it's going to instantly plot it. So the graph x squared is the visual representation of the equation x squared. And I encourage you to do this by hand the first few times so you can get a gist of how the math works, but just keep in mind that the function takes the input and then it generates the plot, the actual function, the graph, as the output. Okay, so let's delete that. So based on that, we're gonna have couple variables, a couple parameters. I'm gonna have the tempo. Let's start at 120 BPM, and then we want to look at let's say the quarter note, which is 1 beat. Okay, so we have 120 BPM and the quarter note, which is 1 beat. All right, and we want to calculate the duration, so let's plug in the equation. D equals 60B over T. Okay, and just like before, we calculated that the duration of the quarter note at 120 BPM is half a second. All right, and like I said, we can vary these and see the duration of the quarter note at any tempo. So maybe like a slower piece might be 70 BPM, and the duration of the quarter note increases, right? So instead of the quarter note, we can look at the eighth note, which is going to be half a beat. And maybe we want to check it at faster piece, like let's make this 140. So at 140 BPM, the eighth note, which is half a beat, is going to be held for 0.214 seconds. This exact number, that many seconds. All right, so that's pretty interesting. And if we so wanted to, we can just vary this from 0 up to 200, and we can say this can be 0 up to, let's say, 8, and we can vary these accordingly. We can see the exact duration for any note we want. Yeah, any note we want. Okay. All right, so that's pretty interesting. So what we can do to visualize this is I'm gonna plot two functions. One, I'm gonna keep tempo constant and plot duration as a function of beats. The other one, I'm gonna keep beats constant and plot duration as a function of tempo. Now let's say the tempo is kept constant, and I'm gonna plot, let's call it D, as a function of beats. So this is going to be 60 over tempo, and I'm gonna multiply this by X so we can see this function. So now if I vary the tempo, we can see the duration as this linear graph. So one thing that might be a little bit tricky when you're first learning functions is that these are parameters. These are not input variables, these are parameters, but the input variable is going to be whatever is varying. So in this case, we're varying beats. So we're going to put beats on the x-axis. So the x-axis represents the beats, and the y-axis represents the duration in seconds. I know that can be a little bit tricky, but just keep that in mind. We're going to do the same thing again, but we're going to do duration as a function of tempo. So duration as a function of tempo is going to be 60 beats over tempo, which is going to be x again. So now we have this graph, and so interestingly enough, we can vary these parameters. Okay, so again, I know it might be tricky what's on the x-axis, but we can see visually what the math is. To me, just this enough is already really interesting, because this shows the duration on the y-axis as a function of tempo or beats, and we're seeing the math of music. That's so cool. To clarify, we plotted two functions. One was duration as a function of beats to give us a linear graph like y equals mx, where the slope changes based on the tempo. Another function was duration as a function of tempo, and the shape of this inverse function is changed by the number of beats. So let's just play around. And what is the significance of this? Well, honestly, there's not too much mathematical significance, but what we can do is plot on the y-axis, we can plot a constant such that the y is going to be the duration. And so what this new function is, this new y, represents at what point are we looking at the same beat and the same tempo. So for instance, if we go right here, so we're looking at let's go to 120 BPM again. Let's go to 120 BPM, and then let's look at a quarter note, which is 1 beat. Okay, so a quarter note is going to be held for, oh look, it's going to be held for half a second. And we can go all the way to the right, see the intersection point. So I'm looking at the intersection point between the red line and the green line, and we can see the intersection point between the green line and the blue line. So we're going all the way to 120 BPM, and look, that's our answer. So if we wanted to visually see this graph, we can use the graph, or we can just use these parameters to see what's the duration for any note we wanted to. I'm gonna leave it at that for this video. This is my entry for Grant Sanderson's Summer of Math. If you like this content, make sure you follow me on my other socials at MathEqualsMusic. Let me know what aspects of math and music that you find fascinating and what other relationships there are between the two.